the extra credit says find the exact value of cosecant squared 23 degrees minus cotangent squared 23 degrees. Now, 23 degrees is clearly something weird. I mean, it's not going to be part of, it's not going to, the only thing that's important about 23 degrees in this problem is that both trigonometric functions are 23 degrees. So I could actually change this if I wanted to, and I'm not saying you had to do this, but you could just say theta equals 23 degrees, and if you wanted to, you could have rewritten this problem as cosecant squared theta minus cotangent squared theta, and done it from there. I'm not saying you had to, but I'm just saying all it is just an angle. It's like a placeholder here for us. So I'm not exactly sure where I'm going to take this, but when I see a trigonometric function squared, it's kind of ticked me off that somewhere the Pythagorean theorem is going to come into place. So the Pythagorean identity is sine squared theta plus cosine squared theta equals 1. B squared plus A squared equals C squared. That's all it's about. So let's start messing with this. So cosecant is 1 over sine, correct? Okay, so this I'm going to change to 1 over sine squared theta. Well, no, I'm going to change it to 1 over sine squared 23 degrees. Minus, now cotangent is cosine over sine, correct? So I'm going to change that to cosine squared 23 degrees over sine squared 23 degrees. And I'm really happy because I have a common denominator. I have two fractions and they have a common denominator. So I'm going to change this to 1 minus cosine squared 23 degrees divided by sine squared 23 degrees. Let me just pause there and make sure everybody's followed me up to here. If I have two fractions, the only way I can add them or subtract them is to get a common denominator. So when we're working with these kind of identities, when we're kind of trying to transform things, it's very common that we're going to be trying to find a way to get a common denominator so that we can add or subtract things. Now, sometimes you'll do that, and it'll just lead you off on some wild goose chase and won't be the right way to go. But in this case, this is the right way to go, because this is the Pythagorean identity. And two things that come off of this like instantly are that cosine squared theta is equal to 1 minus sine squared theta, just subtracting sine squared theta from both sides of this equation. And sine squared theta is equal to 1 minus cosine squared theta, just subtracting cosine squared theta from both sides of the theorem. Everybody see that? So really, I think I mentioned, you know, my buddy John, who teaches math over at Marlboro. This is the only trigonometric identity that he memorizes. All these other trigonometric identities that we're going to get to, he just doesn't even pay attention to. This is the only one he memorizes. Right? And you have to know that from here you can get to here. Right? So if I'm looking at this, I say, well, I have 1 minus cosine 23 degrees. Well, 1 minus cosine theta is equal to sine squared theta, right? So this is equal to sine squared 23 degrees divided by sine squared 23 degrees, and anything divided by itself is 1. Pretty cool. Somebody asked me a question.